Hi, this is Mrs. Boat from Roger Bacon High School, and today we have short notes on 10-3 geometric sequences and series. I say they're short because they'll kind of go quick since we've already been working with arithmetic, same concepts, just different formula we're going to work with. So for a geometric series, in which by this time we all know geometric just means it's being multiplied by a constant ratio rather than being added, like arithmetic. To find the nth term, what we're going to be using is a sub n is equal to the first term times the rate to the power of n minus 1. So variables haven't changed. A sub 1 still first term, a sub n still the nth term, and of course r is the rate. That's just what the r is the new d, I guess you could say. It's what the common difference was in the arithmetic. All right, so to find the nth term of a geometric series, that means what's the term they're asking for. Here they're asking for the 8th term, so we would use a sub 8 is equal to the first term. I'm just using my formula right above. A sub n is equal to a sub 1, which is negative 4, times negative 2 to the power of n minus 1. If you simplify that, a sub 8 should be equal to negative 4 times negative 2 to the 7th. And if you put all that in your calculator, and if I'm warning you, if you're putting this in your calculator, make sure you put parentheses around the negative 2 since you're raising it to a power. So you should get 512. That means the 8th term in this sequence is 512. This is a short sequence, so you could actually just write it out. It starts at negative 4 and you multiply by negative 2 each time, so you should get 8, and then negative 16, 32, negative 64 times negative 2 would be positive 128, and then negative 256, and then we should end up at 512. Hopefully that's 8 digits. 1, 2, 3, 4, 5, 6, 7, 8. Great. 8 terms. So that's all that means. Pretty simple. Example 2 is a word problem. So it talks about heavy rain in Brienne's town caused the river to rise. The river rose 3 inches the first day, and each day after that it rose twice as much as the previous day. So we need to figure out how much did the river rise in 5 days. So again, this is one that you could figure out by hand, but we want to know the formula so that when they ask how much did it rise in the 75th day, we don't want to be writing this out by hand. But just so you understand what we're doing, if it started at 3 and the next day it was 2 times as much as 3, well then it would be 6. And if it were 2 times as much as the day before, it'd be 12. And then of course we'd have 24. Then of course we'd have 48. So we can see this is a geometric sequence. The common ratio here, and the way we find that is take 6 divided by 3, we get times 2. 12 divided by 6, times 2. Times 2. Everything here is times 2. Times 2. That looks like a plus. So does that one. I meant times. Times 2. Times 2. So we could see here, that's how we could do it by hand, but we could also write it out with the formula. A1 is equal to 3, that's the first day. The ratio, common ratio, is 2, and we want to find A5. So A5 will be equal to A1 times the ratio, which I know already is 2, to the power of 5 minus 1. So A5 will be equal to, careful here, don't simplify this to 6. This is not 3 times 2 to the 4th. It's 3 times the quantity 2 to the 4th power. You have to use order of operations here. Common mistake here is for people to put 6 to the power of 4, and that will not be right. You must take 2 to the power of 4 and then multiply it by 3. So A5 is 48. But don't stop here. It didn't ask, and we have to be very careful, how much did the river rise in 5 days? Well, it did raise 48 on the 5th day, but that's not the total. The total that it rose would be all of these added together. So we would have the 3 plus the 6, 12, 24, and 48. So the total would be 93 inches. Now we don't get into the sum formulas till tomorrow. So in a question like this, you would simply be able to write it out knowing the information, and then you need to add those all up. All right, moving on. Write a general equation for the nth term of a geometric sequence. Very simple. First we need to find r. What's the rate of change? Well, the way you look at these, you could take 2 divided by a half, and you would see that would be 4. Then you take 8 divided by 2, that's 4. 32 divided by 8, that's 4. So we can see that each time we're multiplying by 4. So we found r, it equals 4. We know a1 is 0.5, and so we could figure out that an is equal to 0.5 times 4 to the n minus 1. That's it for now. So try that on this one. Press pause and come back when you're done. All right. Hopefully you got a sub n equals negative 0.25 to the power of negative 8, times negative 8 to the power of n minus 1. All right. Easy, easy. Find the geometric means. So this one's a little tricky, but not really. Find the 3 geometric means between 2 and 1250. So this is key here. They tell you how many numbers are in between. Well, if there are 3 in between, that means there are 5 total numbers. There's 2 right here, then there's 3 more, and then there's 1250. So that means I know that n is 5. I have 5 terms. So if I'm trying to find a sub n, of course we're going to use a sub n is equal to a1 times r to the power of n minus 1. Oh, this is getting in the way. I know what a sub n is. That's the final term. So let's use that. Let's use 1250 is equal to 2 times the rate to the power of, and remember we have 5 terms. So I'm basically using a sub 5. I have the information for a sub 5, so I'm using that to find my rate. So here, 1250 is equal to 2 times r to the 4th. If you divide by 2, 625 is equal to r to the 4th. Here comes the tricky part. We want to take the 4th root of both sides. Not too tricky. In your calculators, if you have a graphing calculator, you would hit 4 math and then hit the x root sign. If you don't have a graphing calculator, you could take 625 to the 1/4 power. We did that with rational exponents. Either way, you're going to come up with, hopefully, 5, but r must be plus or minus 5 because we have an even root. So what that means here is we have 2 options. We have 2, 1, 2, 3, and 1250, and we have another option. So it could be, we could multiply by 5, and then we would have 10, 50, 250, or we could multiply by negative 5. We'd have negative 10, and then 50, negative 250. So there are actually 2 answers for this geometric means problems. And that's going to happen every time you have an even root that you're taking. All right, last example for today. Remember, if you need to go back over it, just hit rewind. Find the 4 geometric means between 0.5 and 512. Go ahead and do this on your own. Press pause. There is only one option here. And come back when you have the 6 terms all written out. All right, hopefully you're back. And hopefully you got 0.5, 2, 8, 32, 128, and 512. If not, ask me about it tomorrow. We'll do a little bit of this practice, and we're going to actually extend and go a little bit further and do some more challenging problems tomorrow in class. Have a good night.